Welcome back to Java Internals Crashcasts. I'm Sheila, and with me, as always, is the brilliant Victor. Today we're diving into the fascinating world of Semaphores, a crucial synchronization utility in Java's concurrent programming toolkit.
Thanks, Sheila. I'm excited to explore Semaphores with our listeners today. Before we jump in, let's remind everyone that we're currently in the synchronization utilities season, specifically in the synchronizers chapter.
Absolutely, Victor. And for our listeners, to get the most out of this episode, you should be familiar with basic thread concepts and the idea of shared resources in concurrent programming. That's when multiple parts of a program run simultaneously and interact with shared data. Now, let's kick things off with a quiz question to get everyone thinking. How can a semaphore with 3 permits be used to limit concurrent access to a pool of 3 database connections?
That's an intriguing question, Sheila. It touches on resource management, which is a key application of semaphores. I'm sure our listeners will be pondering various scenarios where this could be useful. Let's keep this question in mind as we explore semaphores, and we'll reveal the answer at the end of the episode.
Great idea, Victor. Now let's start with the basics. Can you explain what a semaphore is and why it was created?
Certainly. A semaphore is a synchronization tool that was introduced by the Dutch computer scientist Edgar Dijkstra in 1965. It's essentially a counter that helps control access to a shared resource by multiple threads. The semaphore maintains a set of permits. When a thread wants to access the shared resource, it must first acquire a permit from the semaphore.
That's interesting. So it's like a bouncer at a nightclub, controlling how many people can enter based on the club's capacity.
That's an excellent analogy, Sheila. Just like a bouncer allows people to enter until the club reaches capacity, a semaphore allows threads to access a resource until all permits are used up. When a thread is done with the resource, it releases the permit, much like someone leaving the club.
I see. So, are there different types of semaphores?
Yes, there are 2 main types: binary semaphores and counting semaphores. A binary semaphore has only 1 permit, so it's either available or not, similar to a lock. A counting semaphore can have multiple permits, allowing a specified number of threads to access the shared resource simultaneously.
That makes sense. How do threads interact with a semaphore in Java?
In Java, the semaphore class provides 2 primary methods: acquire and release. When a thread calls acquire, it tries to take a permit. If a permit is available, the thread gets it and continues. If not, the thread is blocked until a permit becomes available. The release method is called when a thread is done with the resource, returning the permit to the semaphore.
Interesting. But what happens if multiple threads are waiting for a permit? How does the semaphore decide which thread gets the next available permit?
Great question, Sheila. This brings us to the concept of fairness in semaphores. Java's semaphore class can be created in 2 modes: fair or unfair. In fair mode, permits are given out in the order that threads requested them, like a proper queue. In unfair mode, which is the default, there's no guaranteed order, potentially allowing for better throughput, but risking thread starvation.
That's fascinating. Can you give us a real-world example of where semaphores might be used?
Certainly. One common use case is managing a pool of limited resources, like database connections. Imagine you have a system with a maximum of 10 database connections, but you have 100 threads that might need database access. You could use a semaphore with 10 permits to ensure that only 10 threads can access the database simultaneously, preventing overload.
That's a great example, and it relates to our quiz question. Speaking of which, I think it's time we addressed it. How can a semaphore with 3 permits be used to limit concurrent access to a pool of 3 database connections?
Excellent timing, Sheila. The answer is that you would create a semaphore with 3 permits, representing the 3 available database connections. Before a thread attempts to use a database connection, it must call semaphore, acquire. This ensures that at most 3 threads can access the connections concurrently. When a thread is done with its database operation, it calls semaphore.release, allowing another waiting thread to acquire the permit and use a connection.
That's brilliant. It's a simple yet powerful way to manage limited resources. Are there any common pitfalls or best practices we should be aware of when using semaphores?
Absolutely. One common pitfall is forgetting to release permits, which can lead to deadlocks. It's crucial to always release permits in a finally block to ensure they're returned even if an exception occurs. Another best practice is to use try-acquire, with a timeout when appropriate, to avoid indefinite blocking.
Those are great tips, Victor. As we wrap up, could you summarize the key points about semaphores for our listeners?
Of course. To recap, semaphores are synchronization tools that manage a set of permits. They come in binary, one permit, and counting, multiple permits, varieties. The main operations are acquire, to get a permit, and release, to return it. Semaphores can be fair or unfair, and they're excellent for managing access to limited resources, like our database connection pool example.
Thank you, Victor. That's a great summary. In our next episode, we'll be exploring another powerful synchronizer, the countdown latch. Until then, listeners, keep experimenting with semaphores in your concurrent programming adventures. Don't forget to subscribe to Java Internal's Crashcasts and leave us a rating if you're enjoying the series. Your support helps us reach more Java enthusiasts.